Okay, so we've got another video. This one's column level compression in SQL Server. Different to row compression, different to page compression, column compression. Also a different t-shirt. If anyone likes Indiana Jones as a mouse, it's Indiana Mouse. But yeah, so this worked really well the other week when I was doing this at a client site, so I thought it'd be great to stick in the blog post. Not many people seem to know about it, and it's, like I said, column level compression. It's not row level, it's not page level, it's actually at the column. So most people know about row and page. If you don't, quick refresher. So everything in SQL Server is held on 8K pages. If you were to do row level compression, so basically you build your index with data compression equals row. What it effectively does behind the scenes is it turns all of your columns into varchars. So if you've got an integer, which is a 4-byte column, and you're only storing a value of 1 in it, 1 is obviously just one digit, therefore it can actually shrink it down to a varchar 1, frees up some space, does that across all your columns, world is happy, so you get some space back. Page level compression, similar, but it uses a more of a kind of dictionary-esque type algorithm. It's not exactly how it works, but basically it tries to look at your page and say, okay, what have I got that's duplicate, what can I take out? And it tries to kind of take little bits out and squish them up and actually make it a lot more compressed than the row would by basically taking out anything to do with duplication. So that's pretty good. But what people don't seem to know about is as of 2016, you can actually get column level compression. So you can compress and decompress a column. Now I have demos. So what I'm going to do is I'm going to use AdventureWorks. For some reason I'm still using AdventureWorks 2012. I like it, it's good, I'm sticking with it. So run this, make sure my table is gone. I'm just going to make a copy of the person table from AdventureWorks. Plain and simple copy. It's got 20,000 rows in it, it's not too bad. Have a quick look and you can see it is just a kind of messy table, but the key part is we have this big chunk of XML slapped in the middle, and we all know that XML takes up a lot of space. If I click on that, you can kind of see this isn't too bad, this is just a little bit of XML, but the place I was in actually had kind of reams of logging, so right in the middle of the table they just had this one column just full of XML. Pretty ridiculous, but that's how they were storing their data, and you can't kind of redesign once you're at that stage, so they were kind of a bit stuck and everything was grinding to a halt. So if we have a quick look at how much space my new table, this 20,000 record version of this one, takes, and we've got about 30 meg, not too bad, 30 meg, I can live with that. So what we're going to do is we're going to go to the highest level of compression. In fact, what I might do is just row compression, just because. So if I do row compression, just to kind of see how that stacks up. So we'll create an index with row compression, see what that does. Okay, we haven't really done a lot. We're down to 29. I mean, it was 30 meg. We've probably saved ourselves about 400k. I mean, not really that helpful. That wasn't actually part of my demo, so I'm just going to rebuild this again. Okay, so now we've got back to our 30 meg table. I'm now going to do page compression. So if I run that, what you'll now see is, okay, not too bad. I mean, you know, probably about a third off. Bearable, you can live with that. But not what we wanted. So what I'm going to do is wipe that table out, truncate it. I'm actually going to drop the XML column. So dump the column, add it back in again, but this time I'm going to add it in as var binary max. It is XML data, it's going in as var binary, so I'm just going to add that back as var binary now. This time, with 2016 upwards, I'm actually on SQL 2019. But 2016 upwards, you can use compression. So what I'm going to do is I'm actually going to convert my column, and I'm actually going to compress it. So I'm going to run in a compressed version. So this is obviously XML, so I'm going to convert the XML to an varchar, which I can then compress. So if I now insert that into my table, it takes a little bit longer, but that's because it's doing the compression. And now we've still got our same 20,000 rows, just under. Now this one, you'll see data compression none. Okay, purposely not doing any. So I'm going to rebuild this. And now if we check the size on disk, now it's dropped down to 10. So just 10 megs. We've actually locked 2/3 off. We're even kind of 50% of what the page compressed version was. So that's actually pretty good, and that's with no other compression on the table at all. literally just the XML compression. Okay, which isn't actually that bad at all. Now, I could rebuild the entire thing with data compression page. Having done this, you actually only save about another megabyte. It's not really worth it, so I'm not actually going to run that bit for the moment. The key bit I'm actually interested in though is once you've run it, let's set my stats time on. If we actually now try and get 10,000 rows out of that, it's basically about half our table. I'm going to get it from the original table, and I'm going to get it from my new one where I'm actually going to have to decompress the column. So having compressed it, I've got to decompress it and convert it back to XML. So if I run this, okay, what you'll actually now see is the original one was faster, but not massively. Okay, I mean your CPU is a lot heavier, it's doing decompression. So if you're under CPU pressure, you probably don't want to do this. But if you're not, it's great. If you've got overhead, use it. I mean, the actual time is not too bad. That's 10,000 rows. They're not big. Test it in your own environment, but that's not actually too bad. Okay, so this might be kind of the way forward. Now, the other reason I bring this up is because this is how I was actually using it. Now, a lot of people end up doing this type of thing where you have a table with a few kind of small columns that you're doing your kind of searches and seeks over, and then a massive great column on the back that just doesn't really fit with anything. This basically means, so if I kind of drop this just to create my table, I'm going to insert 50,000 rows, and I'm going to replicate X 7,500 times. So basically this is going to mean I can do one row per data page on disk. Okay, because I'm forcing basically 7,500 X's into the table along with A and B. So if I run this, it'll take a little bit just to run in because it's big. There we go, 50,000 rows. Now if I look at top 10, you can see I have this huge column. Now a lot of people end up doing this. I can index it, and I'm just going to index it on ID. Just to read that. Okay, now if I set my stats IO on, so I can see the disk activity, I'm only going to pick out MISC value 1 and 2, and from here they are the small columns. Okay, doing just that based on just an ID. But because there's one data page for each row, if I run that, what I'm actually going to get is 5,000 rows, 5,000 logical reads, which is 5,000 data pages. It's 5,013 just because it has to go down through the index. So you've got a few kind of, you've got to go down the tree, the B tree, to actually get to the bottom. So that adds a few in, but roughly 5,000, which makes sense. Now, what you would generally then have to recommend people do is split it up. So you create a small version which only has your kind of key columns that you're searching on, that you really kind of care about, that you return majoritively. So I'm going to create that, and I'm going to stick an index on it just on ID. Create a big one that now has that same ID in it, okay, but now it's just got that big column. So if we need it, we can easily join these two together. So we do a search on this one for our kind of key values. Once we know which ones we're looking for, we then go and get this one. Okay, so I'm going to stick an index on that as well, just on ID, so we can do the joins. Now stick our data in. And you can see I'm just using our original combined table, and I'm just going to throw the small values in here, the big values in here. Then what I'm going to do is I'm going to create a view. And my view is just going to be called combined 2, so it looks like the table that up here was called combined. So now what I can do is I can say I only want the two small columns where the ID is in that range. And now our reads go down massively, which, to be fair, is the benefit of architecture. If you ever needed an argument for the benefit of architecture, this is it. But you can see we've now only got 16 reads to get effectively the same data out. But, okay, if we actually wanted to pull out our big value, we still now have to do kind of 500,000 records from the big table, which, as we can see here, is going to then end up doing 5,000 reads across our other table, along with some reads from our small table. Combine them together, we're going to get quite a lot of reads, which we again don't really want, so not ideal. But what we now can do, if I drop my big table, is recreate it, but this time recreate the big value as var binary max, so you can tell what's going to happen if you've been paying attention. So now I'm going to insert in exactly the same data, but I'm actually going to compress this one. Now in the background this uses GZIP, so it's actually pretty good. So I'm going to whack in some compressed data. Takes a second or two because again it's got to compress it. YouTube videos that go quiet. Awesome. And then I'm going to stick an index on. Index done. So now what I'm going to do is recreate my view exactly the same as above. And now what happens is if I now say, okay, I actually want the big value to come out for my 5,000 records, because it's now compressed. Okay, you can see I get this var binary max column, but the key part is I only get a total of 56 reads. So instead of the 5,000 and something reads, I now just get 56. And then obviously this is not much use to anybody because we actually need to read this data. So what I'm going to do is I'm going to decompress it, and then obviously convert it because the decompressed is still a var binary, sorry. So it's going to gzip it back to a var binary. We need to then convert the var binary back into a string. So if I now do that, it comes back pretty quickly. So it took less than a second. We actually get the data we're looking for. But again, it's now only still the 56 reads. All we did was slightly increase the CPU. So again, if you've got CPU overhead, brilliant way to actually gain massive performance, cut down on your disk activity. It's all good. The only things I obviously would say are this is heavily compressible. I mean, I'm just using X's. This is, as you saw with my AdventureWorks table, it does work pretty damn well when you're actually compressing stuff down. Like, you can get 2/3 off it pretty easily. This compressed down hugely, but that's because it's just X's, and GZIP is a very good zipping mechanism. So yeah, you wouldn't get this level, but you can see how if this is the kind of thing you've got in your environment where you are actually, for example, stuck with a table that actually just has an XML column right in the middle of it, this might be a good thing to do, to actually try and just alter it into a var binary max and compress it down. If you can actually re-architect and split your big table into two, so you can do nice happy lookups on the small table, and then actually go to your big table just when you need the big data, but then compress that big data down, you again could get huge benefits, not just by the architecture, but also from the compression. So that was it. It was just a very quick note about column level compression, something not many people seem to know about. Column level compression, not page, not row, column. Quite funky. See if it works in your environment. And that's it for today. And don't forget, if you want to know anything about row compression, page compression, they're all covered in our courses. We've got courses on performance, architecture, all the good stuff that you've kind of just glossed over here. But yeah, so sqltraining.co.uk. Come along, have a look, see what we've got on offer. Be there.